Hey there, Beager fifth graders. We are going to tackle a little math this morning, or I guess it could be afternoon, depending on what time you're tackling this. Keep in mind, you can do math or reading in any order that you want today. So if you're doing math first, welcome to your first e-learning day of this school year. We are going to actually tackle your instruction book page first. We're going to be on page 72, and we're going to do the guided practice. All last week, we were working on multiplying decimals. We used the area model, we used partial products, we used what I like to call the old school method, which is just the algorithm or how your parents learned it, in other words. And so today we're going to do a little practice with that. I'm going to help guide you on some of your own practice, and then you're going to take off and do it on your own. Hopefully you remembered to bring your math pages home with you. If you didn't, you can access those pages on Canvas. However, they're going to be a little bit more difficult to manipulate. You'd have to type in things and stuff like that, but hopefully you have your book with you. So let's get started. So we're going to take a look at page 72, and we're going to start by looking at the example problem. Remember, we never ignore the example problem. It's always super duper important. And I want to point out to you that anytime you have these guys here, you want to read the questions and the hints that are given because they can be very helpful in helping you to understand what to do in the problem. But we're going to begin by making the problem make sense. We have to understand the problem before we can solve it. So we have Liam ate 5/10 of a 1 25/100 ounce bag of raisins. Now, of course, I read the decimals correctly. Sometimes it's easier just to read them as quote-unquote slang. That way you can understand it a little bit more. But before you move on, first understand what it is that you're even talking about. So Liam ate 5/10. 5/10. 5/10, that's a half. Okay, so in other words, Liam ate a half of a 1 25/100 or 1 25/100. Well, wait a minute. That's also the same as 1 1/4. So he ate half of a bag of raisins that was 1 1/4 ounces, and he ate half of that. Okay. So how many ounces did he eat? So we're trying to figure out what is half of 1.25. So if you take a look down here, they decided to use an area model. So remember what I said. It seems weird to say that we're going to be multiplying, but in this case of decimals especially, that of means that we are actually doing half of, think of that as of 1.25. So up here you can see that they've put the 1, the 2/10, and the 5/100 there, and then the half over here. So all they're doing is multiplying, let me get my highlighter, a half times a whole, which is a half. Okay? And then over here, they did a half times 2/10. And then on the farthest side, they did a half times 5/100. And then simply add it all up. Okay? When you add it all up, they got 0.625 ounces, which makes sense because this is a little more than a half, right? And think about this. If you took 1 1/4 and thought of that like money, okay, that would be $1.25, just like it showed up here. If you had half of that, let's start with this. What's half of a dollar? 50 cents, right? And lo and behold, that's what this is. Look, half of a dollar. Half of a dollar, 50 cents. Okay? Then we would have to add that to half of 25 cents. Well, we know we can't really divide 25 cents in half evenly in the way that we're thinking. But what if we just said that that was 20 cents? Let's do 20 cents. So it would be half of 20 cents would be 10 cents. So there's another added on to that. That would be 60 cents. Okay. And then what we have left is the 5 cents. And look, 62. See where we're at? Use smart estimating to help you make sure your answer makes sense. All right, let's take a look at this problem. We're going to kind of do this together. What I want to remind you of is you may pause the video anytime that you would like to so that you can solve the problem without me. Sometimes I'm going to tell you to pause the video and do some things on your own, okay? So let me erase some of this, get that out of the way. So Gina rides her bike to work at an average of 10.4 miles per hour. So we got to think about this. So Gina leaves her house and she rides her bike to work, and she can ride her bike an average of 10.4 miles per hour. That kind of makes sense. You got to make this make sense. If you're in a school zone and mom and dad are driving in a school zone, they have to drive about 20 miles an hour, which seems like so slow. So imagine half of that is how fast she rides her bike to work. That makes sense. Okay. So she bikes 1.2 hours each day. Okay, so if she goes an average of 10.4 miles per hour, 10.4 miles per hour. What does that actually mean? It means that 10.4 miles per hour, so in 1 hour, 1 hour, she's able to go 10.4 miles. Okay, let's keep that in mind. 1 hour, 10.4 miles. And it says she bikes 1.2 hours each day. So she goes technically another little 0.2. That's how much she actually bikes each day. Now, if we know that she can go 10 and 4/10 miles in that 1 hour, but she bikes a little bit more than that, she bikes 1.2, I would guess that my answer is going to be a little bit more than 10.4. So let's see what we're going to do here. Okay, what we're going to have to do is multiply our 10.4 and our 1.2. So you can do this several different ways. Many of you probably like the old school algorithm. Now, remember, in multiplying, you don't have to line up the decimal points. You actually do not line up the decimal points. It's all about place value. But I just want to stop for just a minute. Instead of doing just the typical old school, I want to think about this as just plain old multiplying with no decimals. So, if we have 2/10 times 4/10, we get 8/10, right? And then 2/10 times 0 is 0, and 2/10 times 1 is 2. So we're going to leave this kind of old school like this for a minute. But what are we really thinking? We're doing 2/10 times 10 wholes. Where do you suppose that decimal would end up being? Then, what if we think about this, continuing to do it old school, okay? Put a 0 there technically in the tenths place, because we're not multiplying the tenths. We're done with that. Okay, 1 times 4 is 4. 1 times 0 is 0. And 1 times 1 is 1. And add it all up. Okay, and the old school method, which is super cool, we just count how many times how many places we have to jump to get our decimal to this end on both of these. 1, 2, so we jump back. 1, 2. And I see that she rides 12 and 48/100 miles per day. Now, Does that seem logical before we move on? Well, I said that she rides 10.4 miles in 1 hour. So if she goes a little over an hour, 1 2/10, I said that it shouldn't be too much more than what she's already riding. Just 2/10 more of an hour that she rides. So she rides 12 and approximately a half, 12.5, 12 and a half miles per day. So that seems pretty logical. Okay, use that reasonable estimate. All right, let's move on to this one. If a person's hair grows 1.2 centimeters a month, okay, so let me think about that. So let's say December to January, it grows 1.2. And then January, excuse my dog, to February, it grows another 1.2. So each time we're adding another 1.2, 1.2. Okay, I have to make that make sense for me. How much would it grow in 9 months? Oh, look at my drawing. I can already tell that each month we're adding another 1.2. So we're doing 1.2 plus 1.2 plus 1.2. Well, repeat addition is the same thing as multiplication. So if we want to know how much it will grow in 9 months, then we're just going to multiply 1.2 times 9 whole months. Okay, let's think about this without even doing the decimal point. Okay, if we've got, now would it make sense to say it grows 108 centimeters in 9 months? I wouldn't think so, because remember, this is one whole. Let's just round. Basically, it grows 1 centimeter in 9 months. So that would be 9 centimeters for 9 months. And that's by using rounding. Okay? So do you think if our rounding, our smart estimate is 9, that our actual answer would be 108? Probably not. What do you see in this number that looks pretty close to our 9? You should see the number 10. And lo and behold, remember, old school, move it 1 time this way, move it 1 time this way. So your answer should be 10.8 centimeters. Okay? And then the last one we're going to do together, what is the product of 1.05 and 0.7, or in other words, 1 5/100 and 7/10? Well, we know that product means the answer to a multiplication problem. So if it wants to know the product of 1.05 and 0.7, it just means it wants you to multiply those two. And I would think that by this point, your favorite method is probably just doing this old school, but if you'd like to do an area model or partial products, you may. The nice thing is now you've got all these different tools in your tool belt. You know how to do area model, you know how to do partial products, you know how to do the algorithm or old school, and now at this point you get to pick which kind works best for you. Okay, so I'm going to start by remembering that I'm not multiplying this yet. I'm multiplying 7 times 5, which is 35. 7 times 0 is 0, and 7 times 1, oh, I forgot my 3. 7 times 0 is 0 plus 3 is 3, and then 7 times 1. Okay, so done with that one. You can put a 0 there, and remember this is just 0, 0, and 0. But it is important to know that because it may affect your decimal point in the end, so you don't just want to skip that row. So let's see where our decimal point will be. We need to count the places to get each decimal point to the end. Okay? 1, 2, 3. Our decimal point is down here right now. We go backwards. 1, 2, 3. Oh, I sure am glad I put that 0 on the front. So my answer should be 735 thousandths, or 0.735, letter C. Aaron chose C as the correct answer. How did he get that? I want to show you something. Just by using a smart estimate, we can see that this would be 1.05 would be rounded to 1, okay? And 7/10 could be rounded to 1. Oops, let me put that. And what is 1 times 1? It's 1. So logically, we would need the answer that would be closest to 1 whole. Well, this is 73 wholes. That's not going to work. This is 7 wholes. That's pretty big. This is not even rounded. Look at that. That would round that to 1/10. That's very different than 1. So look at our closest answer. This 7 would round that up to 1. Okay, so even if you just wanted to respond by Aaron found the product, by multiplying, they're just trying to prove that you know that the word product means to multiply. By multiplying 1 and 5/100 by 7/10. If he rounds each of those to 1, I was going to say he can see that 1 times 1 equals 1, and 0.735 rounds to 1 whole. I'm telling you, rounding can be your best friend. Okay, so we are done with this practice page. I'm going to go ahead and stop this video, and then you'll move on to the next video, which will be much shorter.